You knew it was coming. Here's the third one. You knew that you're not going to get these nice, wonderful, easy little trinomials to factor. You're going to get something ugly. So what? Do it. You know how to factor this. This is 2x squared plus 5x minus 3. PSA 2. And if you don't know PSA 2, go back to my Math 10 podcasts and read it and weep, baby. Look at that. Minus 6 and 5. So the answer for this, of course, is going to be 6 times a minus 1. That's 6 plus a minus 1. We can't just go directly into the answer. We got to go out and factor, baby. So here we go. 2x squared plus 6x minus x minus 3. Group factorization. Bada bum, bada bum, bada bum, bada bum. Take a 2x out, leaving you with an x plus 3. Take a minus 1 out, leaving you with an x plus 3. Your result is, of course, x plus 3 because it shows up once. It shows up twice. And what's left? 2x minus 1. There's your factorization of your numerator. So let's take this guy and let's put this guy right here. And let's clean this guy all up. Here we go. Okay. Factorization of the numerator is, of course, x plus 3. And, of course, 2x minus 1 all over. Ah, look at that, x plus 3. And look what I see right off the bat. Don't you see it? There it is. Yes, math becomes a musical. Ha ha. X equals to minus 3. There's your point of discontinuity. So put in minus 3 right there. There's your point of discontinuity. You know it. Now, take this guy and substitute it back into the equation here, right? If you substitute it back, 2 times minus 3, minus 1. 2 times minus 3, of course, is minus 6. Minus 1 is minus 7. Your point of discontinuity is at minus 3, comma, minus 7. There it is. Okay, now, here's something that you don't realize, though. I'm just going to erase this again, because we're done with point of discontinuity. But look what we got left. We're only left with 2x minus 1. Interesting. Now, let's talk about the vertical asymptotes. Well, you cancel this out. There are none. But wait a second. Isn't this over 1? Yeah. Which means that, the powers were not the same. The powers weren't the same, which means you could have divided this guy into this. And you know from going way, way back, when this power in the numerator is bigger than the power in the denominator, you get oblique asymptotes. Ah, ha, ha. Do you remember? So your vertical asymptote and your horizontal asymptote are both oblique. They're both oblique, and you can't write them out yet. Well, there is a way of doing this, and I'll tell you what. You come and see me and I'm going to show you how to do this. Okay, so come for a visit sometime and I'll show you. Okay, now let's look at the x-intercept. X-intercept happens, of course, when y equals to 0, right? Now look, 1 times 0, yeah, gee, that's just way too easy. Bring the 1 over, divide by 2, you find out that your x-intercept actually equals to 1/2. Okay, so your x-intercept, x equals to 1/2. Perfect. Let's do the y-intercept now. Y-intercept, go back to the original equation. Look at what you have left. Look what you have left. You have y equals to 2x minus 1. Y-intercept is when x equals to 0. So guess what? That guy's gone, leaving you with a y-intercept minus 1. Gosh, this one's easy. You probably thought this was going to be the toughest. Well, it is one of the toughest, actually. It's that you're just so good at this now. This is becoming easy, right? Right. Okay, let's look at the domain. Domain's real easy. All values of x such that x cannot equal to, all right, what can x not equal to? Minus 3, of course, because that's the one that was in the denominator here that you canceled out. Okay, but x can be anything else. X can be an element of R. Everybody's happy. Now, let's clean this up so I can do the range nice and pretty too. Okay? Now, do you remember what the range was? The range works out to be all values of y such that, okay? Now, think about it. You can only get it from this point of discontinuity. Y cannot equal to minus 7, but Y can be anything else. You're getting so good at these. Go watch these 3 podcasts again. Get really liquid with this, because the next little thing I'm going to do for you is we're going to work backwards. And I think that's going to make something really, really incredible happen. So stay tuned.